Welcome. In this video I'm going to show you how you can perform a post-hoc analysis after a goodness of fit test using Excel, and this will be focusing on using a residual test, which means to only look at each category and their expected counts versus all other categories. If you want to compare each category with each other possible category, then it's a pairwise goodness of fit test. Using goodness of fit test, or you can actually also use binary test. I have separate videos on all of those. I have a separate video also on how to do all of this with my own add-in, the stikpet E add-in, which actually simply just has a function for it, and then you get all the results you want. But in this video I'll do it without that. So I have some example data in column A. It was taken from the General Social Survey, adjusted for some example purposes. From 2012. The marital status was the field that I was interested in, and the first thing I do is I count how often each option was actually chosen. I also add the total in, and my number of categories is, as you can see, simply 5. Now, you might also notice that I'm using a semicolon to separate the parameters. In your system, that might actually be a comma. Now, I could actually use as expected count simply this sum divided by the number of categories. Then the expected count for each category would be the same. In this case, I've chosen to use different ones for each of them. And then the expected proportion is also calculated simply by taking the expected value over the sum. The dollar sign is useful because if I then copy paste it down, it won't actually change. You can toggle this with F4 on the keyboard. And now these are all my expected counts. Then I need to determine the counts for all other categories. So if I'm using married, then the remaining cells is simply the sum of all of them. So that's going to be this one minus the original one, which then also has an expected count of the one I had. And then the other category would be all others, so that was going to be again all of them minus this one, and that goes the same for all of them. Then we need to calculate the chi-square statistic for each possible category. So here are the categories, and then I calculate the chi-square value for the first category, which is then simply the category itself, and this is then for all other categories. I put in all the formulas, so if you want to go over them, I'll leave a link to this file on my website. For all the different possible chi-square tests, I also have separate videos on each of these different tests, but they roughly all calculate some kind of chi-square value. For each, so remember that, for example, for married, the chi-square value is 34.37 if I'm using a Pearson chi-square test. For divorced, it's 0.77, etc. I also need the degrees of freedom, which is actually the number of categories. Well, we each time have 2 minus 1, so simply 1. And then I can finally calculate those p-values, which is simply done by using the chi-square values. And the chi-square distribution, and I want the right tail and the degrees of freedom, which is always that one. Then for some correction for multiple testing, Bonferroni is quite often used. So what you can then do is you'll take simply the original p-value and then multiply that with the number of categories that we actually had. In our case, that was 5. That could then result in a value bigger than 1, and a p-value can never be bigger than 1, so we'll simply put a 1 then. Now, as you can see, for example, for using a Pearson, if this adjusted p-value is below a predefined threshold, usually 0.05, we would speak of a significant result. And it looks like that's only the case for married and never married. This E minus 13 means I need to divide this 5.46 by 10 to the power of 13, so that's very, very small. 0.09 is above 0.05, so not significant, not significant, and not significant. So only never married and married actually had a significant different amount than we'd expected. Alright, I hope this video was helpful, and thank you for watching.